All right, so I want to talk about software architecture. You can Google definitions all you want. At the end of the day, to me, it comes down to this: the relationship between extensibility and complexity. You can build something simple, but it will not be extensible. Or you can do the opposite and design something extremely extensible, but it will be very complex. And it's case by case, finding the right point on this yellow line, this decision point, case by case for what you're doing. So I'm going to walk through a couple of examples and hopefully you'll learn something. So the house analogy, which sometimes works and sometimes doesn't work so much with software, but let's go with it for a moment. So let's say you're designing and building a house, a one-story house, and you do that and it's done. And then 5 years later, the homeowner comes to you and says they want to put a second floor on it, but you didn't put in load-bearing walls. So it would have been an unnecessary complexity to have done that, to be able to extend that, unless you had the thought that they might want to pop the top and actually put a second floor on it. It would make more sense that they would probably just bulldoze the whole thing and rebuild a house. So to put in load-bearing walls on a one-story house, probably not a good decision, right? If you were building that house and you're still just framing it in, would you wire it with fiber? Hey, we have, not initially, but we might one day want to take advantage of fiber for our internet connection. So you make the decision, you wire it with fiber. Let's say it's never used. Wi-Fi is good enough in the house. We never needed to plug anything into fiber, never made use of that. Was it a bad decision? Well, it depends. How much did it cost to put it in? Was it a good insurance policy in case the homeowner ever wanted to use it, even though you never did? So in systems, I'll walk you through three examples and using the N-tier, three-tier architecture, keeping in mind that the criticality increases as you get down closer to the screws. The user tier, user interfaces are easier to rewrite than a middle tier, business tier, where you can have a lot of shared class libraries that a lot of user tier applications are using. And the data tier, the foundation of everything, right? Your data model, it's your database, it's the foundation walls. Changes that you have to do, rework there, causes a lot more complexity because of the cascading effect up. So let's say you're writing a front-end app for a website and you're thinking, well, the mobile, should we have a completely separate project to put all the mobile pages and the mobile site for that? Should we just have one project but then have mobile pages in it? Should we not even have mobile pages and just have the one project be a responsive app or an adaptive app? So these decisions matter because while it's just the user tier and not just, but less critical to have to rework or rewrite a front-end application, it's still important because the decision you make, you'll be living with for months and years, and building things on top of that for all that time to come. So in the business tier, it's a bit more critical because you'll be building class libraries and whatnot that multiple client applications could be using. So for a particular piece of functionality, should we put everything in one shared class library? Should we split it out and have multiple class libraries? For our internal calling applications, should they just hit a class library that direct connects to SQL, to our database? Or should we have an API for that as well, or just keep the API for external applications because we need that greater layer of security going over HTTPS? Or should we have an API, for everything, or split it out? Again, decisions to make. Some decisions are more complex than others, but then with that, they're more extensible than others for things that you want to do. And decisions that you make now, obviously, you have to live with in the future. And then the data tier, where it really, really matters, because you don't want to get this wrong and have to go back and rework a lot of foundational things because of the cascading effect up. Now, you hopefully know third normal form and all of that as far as designing a database properly, but even third normal form is not something you necessarily always have to do because there are reasons why sometimes you don't, performance being one of them. But even in third normal form, let's just look at a couple of examples. You have an employee and a customer entity you've created. Well, they share some attributes. Should you have created a user or person entity. And I wouldn't call an entity a user because that's a reserved keyword in a lot of places. But let's say you create a person entity and take those attributes out of the employee and customer table, put them up to person, and then relate them in a one-to-one relationship. And then your employee attribute or entity can then just have attributes specific to a person being an employee, and the same for the customer, respectively. Is that the right way to go? It's more complex, but it could possibly be more proper and have, when someone goes to log in, what are you working with? Are you working with a person entity that's your login, or do you have to have a separate login for employee and a different one for customer? And how's that all going to work? What would you do with the address fields? Would you throw them in each of these two tables? Would you throw all the fields into a person entity, or would you just have a key in the person entity and split that out and have an address entity that the person relates to? And then even in that, would you normalize that out to city ID or zip ID and how you pick up the country and how that works? All of these kind of things matter as far as how you model the data, how extensible things are going to be in the future, and how limited they're going to be. The last bullet, let's say you want to track what employees are softball players. Would you just slap an attribute on the employee table that says, is softball, and have it a bit yes, no? Or would you create essentially a subclass or a sub-entity, softball player employee, where it has the one-to-one relationship up to the employee, and then you have other possible attributes of that player, like what position they play and what side of the plate they hit from. Maybe attributes, no data that anyone currently says they want to track. They only want to track if an employee is a softball player, but maybe it's something they want to track down the road. How much foresight do you need to have? How much complexity do you need to build in, but appropriately or not? So here's a real world example that let's say you want to feed a pen of animals, and the business comes to you and says, we want to make a call, say, for this coming day, here is the ration that we want to feed and the pounds for each of these 3 feedings a day, breakfast, lunch, and dinner, for this pen of animals. And so you look at the entity on the left, and it's like, okay, we've got this pretty nailed down here. Will there ever be more than 3 feedings? Well, they tell you right off the bat, well, there could be 2. They might feed them more for breakfast and dinner and skip lunch, for instance. It's like, well, that's okay. You could have null values there. That would still accommodate that. No, it'll never be more than 3. All right, it seems like the left is the way to go. Or, you know what, it's variable. It could be 2, it could be 20. Well, if that's the case, you probably want to go to a one-to-many type of relationship that is more complex but more extensible, like what I have on the right. If they say, no, it'll only be 3, and you go with the left, and then down the road they say, you know what, we want the opportunity for a 4th round of feeding. Well, would it have been a bad decision to do what's on the left? Or could you just put in the attributes of round 4 ration, round 5 on your way? So the takeaways of all of this, it's about decision making. Finding the right point on that yellow arrow, case by case. The cost of bad design is high if you go too far to the right or too far to the left in your design. If you design something too simple and limited, and the business wants to do something years later, and you have to say you can't because you didn't design things to accommodate that, then there's the cost to completely rewrite and replace what all has been built. If you make the decision to always go so extensible for everything you do, there is a very big upfront cost for a lot of things that might not ever be needed or realized. You have to use experience, and that's what the second bullet is. It's usually experience that's going to be your best teacher, having gone through years of seeing things and seeing good decisions and bad decisions and learning from those, but to make a wise choice case by case on where to go on that grid of extensibility versus complexity. So good luck, and hopefully you'll make good decisions.